Okay, so when we left off, you were going to try the U-try here, and I hope you found the angle RSU, this yellow angle here, and the green angle TUS were alternate interior angles. They form a Z. And so I hope you equaled them to each other, and you came out with this nice, ugly fraction, -10.7. So we're actually not going to plug that back in. Yes, that's what you got, I hope. All right, so let's just take a look at the top of the next page. We have BHJK is a rectangle, and the measure is angle 1 is 37 degrees. So here's angle 1, and she's 37 degrees. Okay, so perhaps the first thing you noticed is that angle 1 and angle 4 form a Z. They're alternate interior angles. And so right off the bat, you knew that angle 4 was 37 degrees. So I'm not necessarily going in order here. I'm just finding the angles as I can. Other things are angle 1 and angle 2 are complementary. They form a right angle because we know all the corners are 90 degrees on a rectangle. So 90 minus 7 is 53 for angle 2. Let's see, what else? We know angle 3 is kind of tricky. We have this yellow triangle here. And earlier in the same lesson, we figured out that the diagonal pieces are all congruent. And so when you put tick marks on either side of that yellow triangle, it makes that an isosceles triangle, which when you have an isosceles triangle, you know the base angles are congruent. So if that angle 4 is 37, then angle 3 is 37 as well. And then the last one, angle 5, perhaps you used a Z at the angle next to 5, because if I can figure that out, then I know that those two angles combined are 90 degrees. So 90 minus 37 gives me 53 degrees for angle 5. You actually had to find an angle next door and then find angle 5. Okay, so that's example 3. Let's look at example 4 and apply our right triangle strategy with angles. Okay, so we have our 4 strategies: the Pythagorean theorem, 45, 45, 90, 30, 60, 90, and SOHCAHTOA. So here we go. In our first rectangle, we have this right triangle here in yellow. We know that it's a right triangle because this is a rectangle and all the corners are 90 degrees. On this one, I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared. So maybe you have this Pythagorean triple memorized. Maybe you said 5 squared plus 12 squared. You automatically knew that was 13 squared. If not, you can solve to get x to be 13. And then 12 is pretty not too bad. If the bottom is 12, then the top is automatically 12 because opposite sides are congruent on a rectangle. Alright, let's look at part B and figure out which strategy for right triangles we want to use on this one. Okay, so on this one, again, we know it's a right triangle because all the corners of a rectangle are 90 degrees. It looks like this is a 45, 45, 90. So x is 45 degrees. And then, let's see, the formula is n root 2. So that would be 7, 7, 7 square root 2 for y, and x we already found to be 45. Alright, so I've got 2 U-tries down here. Pause the video, give it a try, and then we'll come back together. Okay, so I hope you found out that the first U-try was a 30, 60, 90 simple, because what you had was 30, 60, 90 triangles, 60 degrees, and then across from 60 was in root 3. And so across from 30 had to be 10. And then they didn't ask for hypotenuse, but we know it would be 16. And for y, we know that alternate interior angles are congruent. These are forming a Z, so x is 60 degrees. All right, let's look at the second U try over here. This was a 45, 45, 90 simple, so this is supposed to be 8 on the bottom. Because that's 8 on the bottom, we automatically know that X will be 8 on the top. And then in yellow triangle, let me draw that yellow triangle out here to the side. Kind of hard to see. 45, 45, 90. If the bottom is 8, the formula would be 8, 8, and 8 square root 2 for the hypotenuse. And then here's the cool thing. If it's 8 square root 2 for this diagonal, we know the special thing about rectangles is the diagonals are congruent. So if that's 8 square root 2, then y is automatically also 8 square root 2. Okay?